Good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. First off, I want to welcome you to spring quarter. And then a couple of things I want to mention. So even though these live sessions are not required because you can watch them on YouTube later, throughout the quarter, some of you may not even do that, but I need to tell you, you are responsible for the information that is on these videos. There are some WebAssign has some issues where there's things that you have to do a certain way. And if you don't watch my videos or come to these meetings, you probably won't figure it out on your own. It's not real intuitive on some things. And I will mention them as we go, but especially to do with graphing, which we're going to do today, you have to do things a certain way or it won't accept it. Another thing is it doesn't like mixed numbers. You have to use improper fractions. And another thing is that if you round off a decimal, let's say you've got 4/3. 4/3 is 1.3 repeating. Well, if you write it as 1.3, it's going to be wrong. So unless it tells you to round things off, if you round off, typically it'll be wrong. So you've got to pay close attention to these things, and I will mention them all again as we go along. All right, so what I want to do first off is I want to review some things that it may have been a long time since some of you have done these, but I want to look at how you solve an inequality, okay? Let's start off with how you solve an equation. Let's say you've got x plus 4 equals 10. So to solve this equation, you would subtract 4 from both sides of the equation and you would get x equals 6. Any questions on that? All right, let's say you've got x plus 4 is less than 10. Again, you subtract the same quantity from both sides and you get x is less than 6. Okay, so you can subtract the same quantity from both sides of an equation and from both sides of an inequality. Let's say we've got y minus 8 equals 12. To solve this equation, we would add 8 to both sides and get y equals 20. Let's say we've got the inequality, y minus 8 is greater than or equal to 12. We would add 8 to both sides of the inequality and get y is greater than or equal to 20. So again, not only can we subtract the same quantity from both sides, we can add the same quantity to both sides of an equation or of an inequality. Any questions? All right, let's say we've got 2x equals 10. To solve this equation, you would divide both sides of the equation by 2. Let's say we had 2x less than 10. To solve this inequality, you would divide both sides by 2 and x is less than 5. Okay, let's say you had 1/2 y equals 14. To solve this equation, you would multiply both sides by 2 and you would get y equals 28. Let's say you have y is greater than or equal to, 1/2 y greater than or equal to 14. To solve this inequality, you would multiply both sides by 2. Okay, so you can add the same quantity to both sides of an equation or an inequality. You can subtract the same quantity from both sides of an equation or an inequality. You can multiply or divide both sides of an equation by the same number as well as by an inequality by the same number. Where do things differ? Well, let's say you've got this. You've got negative 5x equals 15. Okay. To solve this equation, you divide both sides by negative 5. But to solve this inequality, if you divide both sides by a negative number, does anybody remember what happens if you divide both sides of an inequality by a negative number?
The sign flips.
The sign flips, right. Okay, Likewise, if we have, let's say, -1/2 y equals 4, and we'd solve this by multiplying both sides by -2, and then we've got -1/2 y less than or equal to 4, and we'd multiply both sides by -2. So basically, if we multiply or divide both sides of an inequality by a negative number, then and only then do you change the direction of the inequality sign. So you got to remember that one thing. Everything else is pretty much the same with equations, solving equations and solving inequalities. Okay, now I want to look at graphing a linear equation. So if you have a linear equation such as 2x plus 3y equals 6, one of the ways we can graph this is to find several ordered pairs. So I'm going to make a table, and I'm going to go ahead and find the x-intercept and the y-intercept. Okay. To find the x-intercept, I would set y equal to 0. So that would give me 2x plus 3 times 0 equals 6, or 2x equals 6, or x equals 3. All right. If I find the y-intercept by setting x equal to 0, I get 2 times 0 plus 3y equals 6, or 3y equals 6. Divide both sides by 3, and y equals 2. So my x-intercept is at 3, 0. My y-intercept is at 0, 2. So having established those points on the line, I can now graph this linear equation. And I'm going to line up my ruler here. And so there is the graph of 2x plus 3y equals 6. Any questions about that? All right. I want to review a second way that you could solve this graph this equation, and that is to put it in what is called slope-intercept form, where we solve it for y. So we would subtract 2x from both sides. Then we would divide each term by the coefficient of y. So we get y equals -2/3 x plus 2. Recall slope-intercept form, y equals mx plus b. So m, which is the slope, is -2/3. b, which is the y-intercept, is 2. So over on the graph, I'm going to graph the y-intercept, which is 0, 2. The slope going from left to right goes down 2 and over 3, down 2 and over 3, etc. And so now that I've established some points on the line, again, I can graph it. Oops, looks like I kind of missed it there. It's tricky to line things up. Anyway, and we get the same answer. If it's been a long time since you've done any graphing, you might want to look in your book, whether it's the ebook online or the printed copy. Chapter 3 of this book is where all this graphing was. That would have been something you would have covered if you took Math 85 or perhaps beginning or intermediate algebra in high school. Okay, now let's get to what we're actually going to do today. This is just sort of the review. Okay. And what I want to do now is I want to switch screens. So I'm going to close this up and open up this other screen. And let's see here. Okay. So can you see the screen that has the grid on it and the X and Y axis?
Yes.
I always ask because sometimes when I switch screens, I forget to push buttons and I'm sitting here talking about something that no one can see. All right, great. Now, what we're going to do is we're going to graph an inequality, I should say a linear inequality. So let's say we've got 2x minus 3y is greater than 6. Okay? Any questions about that? Hopefully not, since I'm just getting started here. All right. Now, this is not an equation, but what I'm going to do is I'm going to look at the related equation, which would be 2x minus 3y equals 6. Okay? So I'm going to change that inequality into an equal sign for the purposes of establishing where that line would be. Okay, now I'm going to make a table. And we'll go ahead and find 3 points this time. Let's see, let's go ahead and use the x and y intercepts, see what that gets, and then we'll choose a different value of x. So if y is 0, I get 2x minus 3 times 0 equals 6, which means 2x equals 6. Divide both sides by 2, x equals 3. So I have the point 3, 0. X is 3, y is 0. Any questions about that? Okay, let's find when x is 0, find what y is. 2 times 0 minus 3y equals 6. Negative 3y equals 6. Divide both sides by negative 3. Y equals negative 2. X is 0, y is negative 2. And just for safety's sake, let's find a third point. How about if we let x equal, let's see. How about we'll let x equal 3. Nope, can't do that. I already used that. Let's see. How about x equals 6? Let's try that. If x is 6, 2 times 6 minus 3y equals 6. 12 minus 3y equals 6. Subtract 12 from both sides. Negative 3y equals negative 6. 6 minus 12, negative 6. Divide both sides by negative 3, y equals 2. So 6, 2 is right there. Okay, good. The points line up. Now, I found the points for this equation. But in fact, what I want to graph is this inequality. And that says 2x less or 2x minus 3y is greater than 6. So it's not equal to 6. Well, if I drew a solid line through those 3 points, that would be where it's equal. But I don't want the solid line. It's not a solid line because it doesn't include equals to. So what am I going to do? I'm going to draw a dotted line through those 3 points. Okay. All right. Now, it says 2x minus 3y is greater than 6. When we're graphing an inequality, we don't get a solid line or just a dotted line. We get what we call a half plane. So think of this grid that you're looking at extending on in all 4 directions infinitely. I'm going to cut that plane in half. And what I've got to do now, I know where my boundary is. It's that dotted line. I need to figure out whether I'm on one side of the line, that is to say above it, so up here, or below it, down there. So what I'm going to do, now I'm going to abandon all of this work in terms of the equals. That was to establish where the line was. And since it doesn't include equals in the actual inequality, it's a dotted line. I'm going to pick a test point. I'm going to pick some point that's not on that dotted line. 0, 0 is always a good test point. So I'm going to pick that. I want to call that my test point. Here's the deal. My solution is going to be everything above or everything below that dotted line. So I'm going to test the point 0, 0. If it works, then my solution is above. If it doesn't work, then my solution is not above, meaning it is below the dotted line. So let's take 0, 0, and let's put it in to that inequality. 2 times 0 minus 3 times 0 greater than 6. 0 minus 0 greater than 6. 0 minus 0 is 0. Is 0 greater than 6? No. So this test point fails, which means my solution is down here. So it's everything below, but not including that dotted line. Okay. And if you're insecure about your test point, well, let's make sure you could pick another test point on the other side. How about this one? Let's see, that would be 4, negative 2. Let's put that in and verify that it works. 2 times 4 minus 3 times negative 2 greater than 6. 8 plus 6 greater than 14. Oops, greater than 6, excuse me. 14 greater than 6. That's true. So the solution is everything below. Now, it's kind of like this situation, okay? Here's my property, and here's the neighbor's property. And there's this fence dividing our property. So the fence establishes the boundary between our properties. But in this case, the fence belongs to the neighbor. So my property is everything on this side of the fence, okay? Now, I'm going to make a very slight change in this problem. Let's say that instead of 2x minus 3y greater than 6, it was 2x minus 3y greater than or equal to 6. Okay? So now, since it includes the equals, it's going to include the line. So now it's my fence, okay? It's still the boundary between the two properties. My property is everything below the fence, but because it includes the equal to, it includes a solid line rather than a dotted line. So if there's an equal to, the line is solid. If there's no equals to, it's going to be a dotted line. Do you have any questions about this example? Okay, let's see. Let's go to the next page and let's take a look at another example. How about this one? Y is greater than or equal to negative 2x plus 5. So I want to consider the equation y equals negative 2x plus 5. Now, again, I can find ordered pairs. So let's see here. I'm going to stick with my intercepts and then some third point, just because I like to do that. If y is 0, we get 0 equals negative 2x plus 5. I'm going to add 2x to both sides. 2x is 5. Divide by 2x equals 5 halves. 5 halves, let's see, as a mixed number would be 2.5. So we're talking 5 halves comma 0 is right about there. Okay. Any questions there? All right. Let's take x is 0 and find y. So y equals negative 2 times 0 plus 5. Y equals 5. So there's our y-intercept. And how about, oh, let's see. How about x is 1? Then we'd have y equals negative 2 times 1 plus 5, negative 2 plus 5, or y equals 3. So 1, 3 is a right about there. Okay. Now, I used the equals to establish the points on the line, since the inequality is y is greater than or equal to, we're going to have a solid line. Let's see here. Line this up. Okay, again, because it included equal to, it's solid. Now I need to find out whether we're above or below the line. Okay, so again, I'm going to use 0, 0. And now I'm going to ignore this, and I'm going to use the actual inequality. Okay, so if x is 0 and y is 0, we get 0 greater than or equal to -2 times 0 plus 5, 0 greater than or equal to 5. Is that true? No. So this is not a good test point. So our solution is everything above and including that solid boundary line. Any questions on that? All right. What I want to do now is I want to go into WebAssign to show you how to graph there, because things can be a little bit tricky. So let's see here. Okay. Let me get into WebAssign. All right. Come on. Here we go. Okay. Let's see here. Almost there. All right. So can you see WebAssign on your screen now?
Yes.
Yeah.
Okay, thank you. All right. Let's take a look at this example. It says graph the inequality x plus y less than 4. Okay. Now what I'm going to do, I'm going to have to do my work on a different screen, and then I'll transfer it back here. Okay. So I've got x plus y less than 4. All right. So we're going to go back to my whiteboard screen. X plus y less than 4. Let's find a couple of points. Okay. Tell you what, let's use the x and y intercepts. So x-intercept, y-intercept. If y is 0, x plus 0. Oh, wait a minute. We're supposed to use the equation, aren't we? Okay. X plus y less than 4. So we're going to look at x plus y equals 4. Okay. That's what we're going to use to establish our ordered pairs so that we know where the line is going to be. Okay, if y is 0, x plus 0 equals 4, x equals 4. If x is 0, 0 plus y equals 4, y equals 4. And how about 2? Let's go, if x is 2, 2 plus y is 4. I need to quit writing so sloppily. I don't know if sloppily is a word, but I'll say it is. So we get 2 plus y equals 4, subtract 2, y equals 2. Okay, so I've got these points, 4, 0, 0, 4, 2, 2. Okay, so what I'm going to do now is I'm going to go back to WebAssign. So my goal here is to graph a linear inequality. So I'm not graphing a point or one of these things we'll talk about later, or a circle. I'm going to start by graphing a line. Okay, so I need to click on this square, and I need to notice I have some options. I have a line with arrows on both ends. I have what's called a ray It has an end point and an arrow, and then I have a line segment. I don't want the ray or the line segment. I need the actual line with arrows on both ends. So I'm going to click on that until it turns blue. All right. Now I'm going to go to my graph and I'm going to plot a couple of points. Recall one of my points was 4, 0. So that's right there. Okay. Another one of my points was 0, 4. That's right there. Now, my third point was 2, 2. I don't actually need to plot 3 points in WebAssign. I just need to plot 2 of them. Okay. So now I've got this line. Can somebody tell me what's wrong with that line?
It's a solid line,
And what should it be?
dotted.
Good. So what I've got to do now, I'm going to go over here and click on line 1 and see where it says dash. We said dotted, they use dashed. I'm going to click on that. Okay. So now I have a dashed or a dotted line, which matches with my inequality there. Okay. It doesn't include equals, so I don't have a solid line. Now I need to figure out which side of that dotted line am I on? Am I above it or below it? So again, let's pick a test point and let's go with 0, 0. So I'm going to go back to my whiteboard and I'm going to consider the actual inequality. So now I'm ignoring the equation and I'm going to put in the test point 0, 0. So that's our test point. Okay, 0 plus 0 less than 4, 0 less than 4. That's true. True. So 0, 0 is part of the solution. Okay. So now I'm going to go back here. This point right there is part of the solution. So that means I want to shade below the dotted line. How do I do that? I click on fill, then this thing comes up and I click OK, and then I click down there. Okay, and notice I can switch it, I can put it there, but there is where I want it. So I've got a dotted line establishing the boundary, and I've shaded everything below the line. Okay, let's see if I'm correct. And check, it says that it's correct. Okay. All right. Any questions about that particular problem? All right, I want to take a look at, let's see here. Let's do this one. So we've got y is greater than or equal to negative 7x plus 5. Okay, so let's go back to my whiteboard. And again, I'm going to find some ordered pairs. Again, let's use the intercepts and see what we get there. Okay, so if and we're gonna consider the equation, right? Not the inequality, but the equation. You'd never guess that I got an A in penmanship in first grade. Of course, when it came to cursive writing in 6th grade, that was another story. There's a reason they call it cursive. Okay, so if y is 0, we get 0 equals negative 7x plus 5. We'll add 7x to both sides. 7x equals 5. We'll divide by 7, and x equals 5/7. Okay. And then let's find the y-intercept by setting x equal to 0. Y equals negative 7 times 0 plus 5. Y equals 5. Now, if you're sitting there going, well, that's the y-intercept because it's in slope-intercept form, you're absolutely correct. Okay. So we've got those 2 points, 5/7 comma 0 and 0 comma 5. Okay. Any question about that? All right. So 5/7 comma 0 and 0, 5. Okay, so again, I'm going to click on this until it turns blue and I've got the line, not the line segment or the ray. 5/7 0. Wow. 5/7 0. Oh, I think that's right about there. Oh, it didn't like that, did it? Well, I'm going to come back to that in just a minute. And then 0, 5. Okay. Now, my points didn't show up where I wanted them to. The 0.05 showed up, but the 0.570, this one right here, I tried to click on what I thought was 5/7 and it took it over there. So how can I fix that? Well, I go over here and I click on the line, and right here it has the coordinates of the 2 points in the order that I put them. So my first ordered pair should be 5/7 0. So I'm going to come in there and I'm going to delete that and I'm going to put in 5/7, and there you go. Okay, see how I did that? Now, let's say it had been 4/3. If you put in 1.3, that's not correct because it would be 1.3 repeating. So stick with fractions. Also, don't use mixed numbers here. Okay, you can only put in decimals if they're exact. Now, any questions about how I fixed my ordered pairs there? My inequality is greater than or equal to. So should my line be solid or dashed?
Solid.
Good. So now all I need to do is figure out which side of those two, or which of the two sides of the line should it be on. Again, 0, 0 is always a great point to use as a checkpoint unless it's on the line and then you have to pick something else. So I'm going to pick 0, 0. So I'm going to go back to my whiteboard screen. Okay. And I've got this, which is what? Y greater than or equal to -7x plus 5. And I'm going to put in 0, 0. So 0 greater than or equal to -7 times 0 plus 5. 0 greater than or equal to 5. Is 0 greater than or equal to 5? No, it's not. So 0, 0 is not a good test point, which means that we're not going to shade the side that has 0, 0. We're going to shade the other side. So fill. Click OK. So that should be the correct solution. Let's find out if it is. And it is. Good job, Ben. All right. Any questions about this one? Okay. Let's do another one. I'm trying to find one. Maybe it's back here. I think I used them all up. Tell you what, let's do this one again. And I'm going to do it a different way. This is a second method. And I use this secondly because not everybody's comfortable with this method. And so if you're not, then stick with the first method I showed you where you find ordered pairs. You put the line, whether it's dashed or solid, you pick a test point to find out what side of the line it's on. But let's say we've got an inequality. Okay. And this one is already in slope-intercept form. And if it wasn't, I could put it there. So what's the slope? The slope is -7 and the y-intercept is 5. Okay. Any questions about how I got that information? So now, oh, I see that somebody sent me a message in the chat. I don't have time to look there. So if you have questions that you're wanting to send me, send them to me in an email if you don't want to just speak out in class, because I've got so many things going on here. I don't look at the chat during the thing. So as I mentioned, if you want to get in touch with me, email me. Okay. All right. So what do we know here? We know that the y-intercept, oh wait, we've got to get a blue line. The y-intercept is 0.5, so that's right there. Okay. Now, the slope was -7, which means we're going to go down 1, 2, 3, 4, 5, 6, 7, and over 1. Okay. So I graphed the y-intercept, and I graphed another point using the slope. It says y is greater than or equal to. Since it includes equals to, it's a solid line. But now, because it's in slope-intercept form, I don't have to use a test point. I can look at the inequality. It has to be solved for y, though. This says y is greater than or equal to. Well, greater than would be above the line. And over here, this is below the line. So I'm going to fill it on that side. Okay. So by having it in slope-intercept form, I can plot the y-intercept, use the slope to get a second point, look at the inequality. If it says y is greater, it's going to be above it. If it says y is less, then it's going to be below it. Okay. Let's do this one that same way. Let's use slope-intercept form. So we've got 8x plus y greater than or equal to -4. Okay. And let's see here. Can I go back to tell you what I'm going to look at that? Are you going to post this on YouTube today? Yes, I lied. I went ahead and looked at the chat. Yes, I'm going to post it on YouTube. Everything I do here will be posted on YouTube for the world to see. Okay. All right. Anyway, so here's the whiteboard. 8x plus y greater than or equal to -4. So I'm going to subtract 8x from both sides. Y is greater than or equal to -8x minus 4. So the slope is -8 and the y-intercept is -4. Okay. So I'm going to graph here. The y-intercept is -4 and the slope is -8. Oh, I can't go down -8 and over 1. Slope of -8 over 1. Shoot. Well, so I guess I could go back and I could find ordered pairs. There is another thing I could do. Let's see if this makes sense to you. My goal here is not to confuse you. If I'm graphing this thing and I have a point here at 0, -4, and I'm going to go down 8 and over 1 and down 8 and over 1, going backwards, wouldn't it be back and up 8? You see that? So in other words, down 8 and over 1, down 8 and over 1, going from there, I could go back 1 and up 8. And if that confuses you, use the other method. So basically what I'm saying is I'm going to go back 1 and up 4, 5, 6, 7, 8, right there. Solid or dotted?
Solid.
Okay, now when I solved it, it said y is greater than or equal to -8x minus 4. So greater than, y is greater than. So it would be above. If it was less than, it would be below. So fill here and submit answer.
I have a question.
Yes.
So just curiosity, instead of doing the reverse and going -1 up 8,
Yes.
Could you go to the line coordinates and type them in like that? Would it accept that even though the line isn't necessarily on the graph?
Let's find out. That's a good question. Let's find out. Okay, so tell you what, let's clear this. I've never tried that. Okay. So we know that it was what, 0, -4. And let's just put our other point here, okay? Now, where does that point need to be? If we go down 8 and over 1, down 8, that would be what, -12, comma 1?
Yeah.
All right. So this is going to be -12. Let's see what happens. Oh, sorry. There we go. It won't let me do it.
Okay, thank you.
Yeah. So the point of all this other method, let me go back here to the whiteboard. And I may have tried that in the past and forgotten, but if you're going to use slope-intercept form, the nice thing is that if your y-intercept is a nice value and your slope doesn't take you off the graph, it's easy to plot and it tells you whether you're above or below the line. But if you get something where the numbers are nasty, the slope is, or the y-intercept is some fraction, then things get kind of tricky. So I would say, unless you're really comfortable with it, the first method is probably a safer way to go. But in terms of, let me go back here. How about this one, for instance, y less than 4x? That's already in slope-intercept form, isn't it? The slope is 4, the y-intercept is 0. Okay, so the y-intercept is 0, the slope is 4, so it's going to go up 4 and over 1. Okay, oh, but it says y is less than, so my line is dashed. But if y is less than, that would be below the line. So that one went very quickly, maybe too quickly for you to follow, because it's already in slope-intercept form. It's solved for y. The y-intercept is 0. There's nothing there, so 0, 0. The slope is 4, so I went up 4 and over 1. It doesn't include equals, so it's a dotted line, and it says y is less than. So we graphed below it. Let me see. Oh, how about this one? Y is greater than -5. That's kind of strange. Y is greater than -5. There's no x in it, is there? Well, let's take a look at the whiteboard again. Do you remember what y equals -5 looks like? If you have a linear equation that just has one variable y,
It'll just be a line going through -5.
it's a horizontal line. X equals a number is a vertical line. Y equals a number is a horizontal line. So if I'm going to graph y equals -5, okay, that means that, let's see, y is -5, x can be anything it wants to be. So there's a point and there's a point, okay? But it says y is greater than, so should that line be solid or dashed?
Dashed.
Okay. Now, y is greater than, so are we above it or below it?
Above it.
Above it. If it's greater than, it's above it. If it's below it, it's, or if it's less than, it's below it. Sorry. So there we have that situation. Look at this one. So there again, you're going to have to use, most likely you're going to have to use your ordered pairs over here and put in specific things. Okay, tell you what, let's do this one. So we've got x minus 1.6 less than or equal to 0. Okay, now this inequality doesn't have y in it. Okay, so let's look at x minus 1.6 equals 0. If I add 1.6 to both sides, I get x equals 1.6. That's a vertical line going through x's 1.6. Okay. So now, let's see here. So x is 1.6. That's going to be right about there. X is 1.6. That's, oh boy, it didn't do what I wanted to do at all, did it? But I can come over here. Let's see. X is 1.6. Whoops. 1.6. And y is 0. That's this first point. Here, x is 1.6 and y is 3. Okay. So that's how I'm going to get my 1.6 by using this over here. Is this going to be solid or dotted?
Solid.
Good. Okay, now let's go back to the whiteboard. If I take this and solve it for x, I get x is less than or equal to 1.6. So where on the graph is x less than 1.6? We can't do above or below because we're not dealing with y, we're dealing with x. So where is x less than 1.6? To the left or to the right?
To the left.
Correct. And there is our graph. Okay, so I will be posting this on YouTube later this afternoon. I have another class right now. When that class is done, before I head off to lunch, I get those going in terms of getting posted on YouTube. I'll be back this afternoon from 1:15 to 2:15. It's a different Zoom ID number for an office hour. If you want to come back with questions there to join me. Again, remember when you're graphing inequalities, linear inequalities, you want to use this button right there, not this one or this one. And you want to choose the line, not the ray or the line segment. And over here, you can make it dashed or solid, and you can change your ordered pairs. All righty. So with that, I am going to stop the recording